on every single one of these problems, we're going to choose 8 pens. Okay? Remember that, because even on this one, when I say that we choose exactly 2, it's implied that we're choosing a total of 8. Okay, so I did that for a reason, because there's some problems in the book that are confusing if we don't think about it. Okay, so there's 20 pens in the desk, 8 are blue, 10 are red. Okay, find the probability of choosing exactly 4 blue and 4 red. Okay, so I'm going to tell you this, that the thing that I want you to kind of refer back to when you're doing this, and I think you guys are doing a pretty good job, they seem to understand the concept, is think about that 3-letter circle and that 3-number circle, and I'm choosing 2 of the numbers paired with any combination of the letters, right? So make sure that you're still using your multiplication rule of counting and thinking about that. Right, so like yesterday, didn't we say that if we wanted to choose 4 total symbols, and 2 of them were for there, and 2 of them were from there, then that would be the total number of ways that you could choose a group of 4 with 2 from the first group and 2 from the second group, right? So that's the same problem. You're choosing 4 from the first group and 4 from the second group, so then you're going to take the way you can do this, which is 8 choose 4 times 12 choose 4 divided by 20 choose 8. Okay? That seem reasonable or not reasonable? Seems reasonable? So I've got the numbers here for you. So it's going to be 70 times 495 over 125,000. And that would end up being a 270 or 27.5% chance. Okay. Any issues? What's going on with what we're doing here? The tough part is you just can't list all these possibilities. So you got to refer back to something simple and apply that same process here. Okay. Okay, let's do this one. How many we picking? How many we picking?
8.
Thank you. But 2 of them are blue, and again, it's implied that 6 are red. Okay? So, 2 blue and 6 red. Same denominator. 20, right? 20 choose 8. 8 choose 2 times 12 choose 6. So that one's a little bit lower, 20.5%.
What's the second number?
This one here?
Yeah.
924. All right. How many pens are we picking? 8, right? So there's 6 blue, and we have to have at least 6 blue, so that would mean that I could either have 6 blue or 7 blue or 8 blue. Again, 6 blue and 2 red, 7 blue and 1 red, or 8 blue. So that's really what we're looking at here. And then let's talk about how to find that, okay? So 6 blue and 2 red, or 7 blue and 1 red, or 8 blue. Now, these are mutually exclusive events. Okay, so then really all you're going to do is the same thing that you would do here, like if you're rolling a die and chances of getting a 1 or a 6. How many ways of doing that? 1 plus 1 over 6. So your chances of rolling a 1 or a 6 or 2 out of 6, the chances of this happening or this is just going to be the sums of the ways you can do this and the ways you can do this and the ways you can do this out of the total number of ways. Okay? So, eight choose 6 of the blues, 12 choose 2, 8 choose 7, 12 choose 1. Now, as far as the 8 choose 8, there's one way of doing it. That's 1. And really, if you wanted to, you don't need to. 12 choose 0. That equals 1 right there. So this is 1 and 1. So there's one way of doing that whole thing. So that's only about a 1.5% chance. So I'm gonna do one thing here with you. So there's 12 reds on the board here, and there's 8 blues. Just, I want you to think about this again. This, choosing 7 blue and 1 red. So I could do this. How many ways are there of choosing 7 blue? There's 7 blue. There's 7 blue. There's 7 blue. So if I cover up 1, there's 7 left, right? So if I had those 7, I could choose those 7 and that red, or those 7 and that red. So really it's going to be 8 possibilities for choosing 7 blues times 12 possibilities for that 8th pin, right? So it's going to be 12 times 8. Okay. So that's kind of nice that you can actually see one here instead of like these. You just can't see all the possibilities. Okay, let's do this. Let's just talk about this one here. Maybe we don't need to do all of it. I think that we're probably pretty good as far as the math of this. But what would this be? At least, or at most, 2 blue pens would mean 2 blue and 6 red, or 1 blue, 7 red, or 0 blue. Right, so you would have to have that 0 possibility in there as well, right? So 2 blue, 6 red, or 1 blue, and 7 red, or 0 blue, and 8 red. Because there is a way of getting 8 red. There's lots of ways of getting 8 red if there's 12 total, right? So let's write down what it would be. And then I'll give you what the answer would be. I always forget how many are in each set, so I gotta it's easier if I look. So 8 choose 2 times 12 choose 6 plus 8 choose 1 times 12 choose 7 plus 8 choose 0, which is 1 again, times 12 choose 8. And that would work out to about 26% chance. So I think that from what I've heard you talk about from yesterday, you seem like you understand this concept, so it's really not that much different. Okay, let's do one problem off of our assignment, and then I'll let you work. Okay, page 177. We'll do number 51. Okay, so number 51 says that we've got 24 first shift workers. Can you say that really fast? 5 times probably. Maybe not, right? First shift workers, first shift workers. Okay, and we got 17 second shift workers. So we have a total of 41 employees, okay? So the question is, and it says, here it is, and this is why I did this, kind of modeled this. There's 8 workers that are chosen. How many workers are chosen? 8, okay? Find the probability of choosing 6 first shifters. Well, again, there's lots of ways of doing this, but you're not just choosing 6 people, you're choosing 6 people combined with options for the second 2 out of the other shift. So you have to count all those possibilities. So again, it's not that much different from what we've had. You have 41 workers to choose from. You're choosing 6, so there's a total. That's our total number of ways that we could choose this set to be interviewed. 8, not 6, sorry, 8. Okay, and so we're choosing from the first shift, we're choosing 24, choose 6, times 17, choose 2. I don't know if you've noticed this yet, but on these problems, guess what the total that you're choosing from in each of these things have to add up to? And then the one that you have as the part chosen out of the first one and the part chosen out of the second one has to total at the end. Okay. So I don't know what the answer is to this. Remember, second enter, you can get your command back and just change the numbers. I got a pretty high number. If I did it right.
19.2 or 19.2%.
That's what I got.
Yeah, the book says
19.2.
1192.
Yep.
So go ahead, work. Let me know if you got any questions.